chances are you were like, I didn't really get it, right? And it is odd and even functions. And if you were in Algebra 2, you don't even know what I'm talking about, right? So we're going to dig a little deep today, but I feel like even for some of my Algebra 2 trig friends, you're going to be like, oh, I kind of remember doing this, and I didn't like it. But my goal is for you to like it. Okay, so here's what I need you to draw on your paper. I need you to draw a basic one of these. I don't need it to be fancy. I need it to look like this. I need it to go like, yay, just like that. Yep, nothing fancy. Today we're talking about symmetry of functions, of graphs. We'll just say of graphs. We're going to talk about symmetry of graphs. That's what we're doing today. We're going to have two parts of our homework. Your homework will be very easy. You're going to get it done in class. But one part will be you will like. It's literally a little checkbox thing, and it's just looking at pictures. And you're going to be like, oh, I love this. And then the second part is doing the exact same thing, but with math. And you're going to be like, ew, don't like that as much. And my answer to you is too damn bad. You picked it. Okay, so here's what we're talking about. That there are ways that we can decide if graphs are symmetrical. And what symmetrical means is that they mirror each other, right? That you can mirror a graph. And a graph has symmetry if it can look one way and then you can mirror it another way, right? And it turns out there are a variety of types of symmetry, right? And we're going to talk about 3 types today, but there's a 4th one that we're going to talk about later, and that I'll talk about that later. But the first type that we're going to talk about, and you want to write this down, let me get a little pen. The first type is called y-axis symmetry. And that is the easiest one. It's super easy, and we like it. And what y-axis symmetry says is, if you take the y-axis and pretend it was a mirror, does it cut your graph in half, right? Does this side mirror this side? And in this case, it totally does, right? How do you test for y-axis symmetry? You draw a line down the middle. And if it mirrors it, yay, it's got y-axis symmetry. It's one of our favorite ones. It's nice and easy, right? So take a look at these two guys. I'm going to go ahead and I am going to take my little drawing and think, yep, I could do that guy, and he's got y-axis symmetry. And I can take this guy, and he also y-axis symmetry. And the first part of your homework tonight is going to be looking at graphs and literally doing a little checkbox and saying, does it have y-axis symmetry? We like that. We like things that have y-axis symmetry. The next type of symmetry that we talk about is called x-axis symmetry. Now, we're not going to talk a lot about x-axis symmetry in this class, and I'm going to tell you why. Obviously, x-axis symmetry, instead of putting my mirror up and down, it's like my mirror is a lake. I'm looking down, and I'm seeing it reflected back to me, right? So it would be like if your mirror is lying on the ground and you look down, does the top half mirror the bottom half, right? And here's why we don't use this in this class very much. Because anything that has y-axis or x-axis symmetry is not a function. Look, if I plug in 4, I get this guy. And if I plug in 4, I get this guy. Remember what we said? If it can give you 2 different answers, it's not predictable. It's not a function. So anything, oh, why did it do that? Anything with x-axis symmetry, you want to write this down, is by definition not a function. It's interesting, and it might be a cool shape, but it's not going to be a function. It's not going to be a function, right? Now, the last one we're going to talk about today is my favorite one, and it is called origin symmetry. And look, I spelled it wrong all day. And origin symmetry is actually called point symmetry. And the reason it is called point symmetry is that it's not a line, it's a point. And it would be, imagine if you took a nail and you hammered a nail in here and you spun it 180 degrees, would you get right back to where you started from, right? So I tried to last night make a cool one. This one sucked. But wait till I show you this one, because I'm very proud. Oh, that's not it. I'm very proud of this one. Are you ready? So I am going to do this one. I'm going to show you that it has origin symmetry. Oh, I'm so proud of this. I have no friends, and this is why, because this is what I do. Okay, so watch what I'm going to do. I'm going to take this guy, and I am going to imagine my pen is right there in the middle, and I am going to spin it 180 degrees. And look, I did that. That's impressive. I'm right back to where I started from. That means it's got it means it's got point origin symmetry. We use those words correctly. Point origin symmetry. Can you make it go around? If I had done this one decently, it would work, but I got off a little bit. I'm going to show it to you anyways, and you'll be like, oh, you tried. Because look, I really did try. I tried super hard, but look what happened. It moved. So pretend it didn't. Pretend I didn't suck at this. Come over here, dude. There. Pretend it got back there. So that would be x-axis. It would be origin symmetry, right? Can you spin it? So I had some kids today who were doing these in the class. They put their pencil in the middle and they spun it. And if it got back to where you started from by spinning it 180 degrees, it's got origin symmetry. It's got origin symmetry. Now, here's the reality in life. The reality in life is most stuff has no symmetry. That's just a line. Does it have x-axis symmetry? Nope. Does it have y-axis symmetry? Nope. If I spun this, would I get right back to that place? No. You know what would happen if I spun it? Ooh, actually, I think I could spin it. Let's try it. Let's see if I can spin this dude. Let's see if we can spin him. Ooh, so here he goes. So if I spin this guy, look what happens. Actually, what would happen, to be honest, if I spun him around here, he would end up down there. He would end up right there. So he would spin down. So he doesn't have, so sometimes they got nothing. Most of the time they got nothing. And that's okay. But sometimes they got a lot. Sometimes they have everything, right? So check this dude out. If you had a little box right here that said x-axis and y-axis and origin and none, here's what you get. Let's take a look at him. It's pretty cool. Does he have x-axis? Yeah, sure. If you cut him in half, he's good. Does he have y-axis? Yeah, he does. And even if I spun him, I don't know if it's going to let me spin him. Oh, look, there he is. Oh, I'm so excited. If I spun him around, look, he's perfect. So sometimes they have more than one. Yeah, so that can happen. But that's symmetry of looking at graphs. And if they give you the graph, and if you're taking the SAT test next week or the PSAT, and it says which of these graphs it's going to be in a minute. I'm going to talk to you. It's called even graphs, and they give you the graph. If you can do some stuff just by eyeballing it, you're going to get some points. You're going to come back in on Thursday and be like, hey, I got that problem right. And I'm like, yay for you. Okay. Now, what can also happen on the SAT test is that they don't give you the graph. They don't give you the picture. And if they give you the picture, it's really easy to talk about symmetry. But if they don't give you the picture, we need another way to test for symmetry. So here's where I need you to write this down. Oh, this looks scary. Determining functional symmetry with algebra. You're not going to love this. I'm going to use some words here that are going to trigger some of you. It's going to give you a little PTSD in a minute. But you're going to be fine. You're going to be fine going through this. So here's the good news. We will not be testing for x-axis symmetry in algebra because anything that has x-axis symmetry in algebra is not a function. And in algebra, that's us. We are third level algebra, right? Algebra 1, algebra 2, pre-calculus, third level algebra. We like functions. So we're not going to worry about that. Yay. We're going to be working with this guy, x-axis symmetry, and this guy, origin symmetry. But they use a different word for these. And they use this word. They call anything with y-axis symmetry, it's going to be called an even function. And this guy is called an odd function. So what they will do on an SAT ACT is they're going to give you like 3 graphs, 4 graphs, and they'll be like, which one of these is an even function and which one is an odd function? And here's what you would say is if you have that y mirror, it would be even. If you could spin it, it would be an odd function. Now today, we're gonna split this. We're gonna do this today. We're gonna do this on Monday. And that's where a lot of you in Algebra 2 Trig got confused because they did it all in one delicious lesson. And people were like, what? I don't get it. So we're going to just do this today. And all you're going to put down on your problems is, yes, it's even, or no, it's not even, right? Because a lot of them are not, it's not even or odd. A lot are nothing. A lot are nothing, okay? So are you ready? We're going to have to do this and I'm going to show you some stuff that's going to look scary, okay? Don't panic. Don't write this down. If you were looking in the textbook, or your teacher was teaching from a textbook, this is what they would show you. And you would be like, I don't even know what that means. And I'm going to tell you in words what it means. What this means is if you have a function and you plug in a number like 7 and you get an answer, and then you plug in -7, you should get the same answer. Let's see what I mean by that. Let's say I plugged in the number 2. Plugging it in, and look, I get 4. And then I plug in -2. Look what I get. I get 4 again. That means it's even, right? So here's what I want you to write down. The definition of an even function. Here we go. Any function Okay, this looks scary. Any function where a domain and its inverse gives the same answer or range. Meaning if I plug in 3, I get an answer. I plug in -3, same answer. I plug in 100, I get an answer. I plug in -100, I get the same answer, right? That means they are even functions. Now, here's the problem, right? Here's what's going to happen tonight. You're going to be given something like this. And here's what we're tempted to do. We're tempted to say, okay, Miss T, I got you. I'm going to plug in 2. F of 2, I'm going to get 2 squared plus 7, and I get 11. Is that good? Is everybody cool with that? And then I'm going to plug in -2. I get -2 squared. What is -2 squared? 4. 4 plus 7. Check that out. I get the same answer. And you're kind of tempted to say, see, I proved it. And the problem with this is, in algebra, we can't just plug in random numbers, because maybe 2 will work, and maybe 3 will work, but maybe 10 won't work, or maybe -64 won't work. And we don't want to plug in every number in the universe. It would take too long. Okay, so here's where I'm going to trigger you. So what we're going to do is use what's called an algebraic proof. It's not scary. It just means we're going to plug in a letter. And if I can make it work for a letter, then it works for everything. Does that make sense? So we're not going to freak out on this because I'm going to call it an algebraic proof. We're going to plug in a letter and I'm going to show you how it works. You guys ready to do this? Okay? So here we go. But we already know this should be even because look, we tried it with 2 and it worked. So let's see if it'll work for a letter. Okay, big deep breath. We got this. Here we go. Now, you are welcome to plug in any letter you want to start off with. You could plug in D for Dana. You could plug in W or T for Thomas. You could plug in T for Topher. You could plug in C for Ken. I don't care what you plug in. Or if you're super lazy, you could plug in X and just stick with X. I don't care. But I am going to plug in D for Dana. So here I go. I'm going to start here, and I'm going to plug in a D for Dana. And here's what I get. D squared plus 7. And if you're like, can I just plug in X? Can I just take the beginning one? You can't. You can't. Now, here's what I need you to know. If this is going to be even, I need to get back to this guy. That's my home base. If I can plug in the opposite and get that at the end, I am good to go. Is everybody cool with that? Okay, so here I go. I'm going to show you the kind of shortcutty way, and then I'm going to show you what I do, because for a lot of kids, it will make this easier. What we now need to plug in is the inverse of D, the opposite of D. And you know what the opposite of D is? Negative D. So here's what I'm going to do. I am going to use parentheses, and I'm going to say negative D squared. Oops, negative D squared. That looks awful. Plus 7. Now, we could, for some of you right away are going to say, hey, negative D and negative D, those negatives are going to go away. And I am going to just get plain old D squared plus 7. Hey, wait a second. That's exactly where I wanted to go, and I'm done. But I'm going to show you a different way to do this for those of you, my friends, who are like, what did you just do? Watch what I'm going to do and see if this helps you. I do it this way. I'm not going to plug in just regular negative D. I am going to plug in, check this out. Oop, come back, get out of here. I'm going to plug in oh God, stop doing that. I am going to plug in -1. Is everybody cool with that? I'm going to plug in -1D. And here's why I do this. Because what I'm going to do is this. -1 squared D squared plus 7. Is everybody okay with that? What happens when I do -1 times -1? It's 1. It goes away. It's just gone. I'm left with D squared plus 7. That's what I wanted. I have an easier time seeing these with the -1. Do you have to do the -1 if you're a pro? You don't. But if you find you are missing these later on when these get a little tougher, use the -1. Is that cool with everybody? Okay, we're ready to try a real one. You guys ready? Here we go. Now we know what we're kind of doing. Okay. We want to know this baby's are even or not. That's how we're looking. It's even or not. And I'm going to walk you through it. Okay? Step 1. Plug in some letter. It can be X. It can be something new. I don't care. I am going to use a D again because it makes me happy. 3 D to the 4 minus 3 D squared. I think on your homework I just kept plugging in X like a man. Now that's our home base. So now what we need to do is we need to plug in the opposite of this guy. So watch what I'm going to do. I'm going to plug in -1D. That's what I'm going to do. And I'm going to do it very carefully. So here we go. 3, -1 to the 4th, D to the 4th. Have I lost anyone there? And then we're going to go minus 3, -1 squared, D squared. So far, so good. Plus 1. Okay. Obviously, this and this don't look alike yet. So let's keep going. Hey, what happens if I go -1 times -1 times -1 times -1? What happens to all those negatives? The positive one, they cancel out, right? They all cancel out. So yay. Boom. Here we go. The -3 comes down. -1, -1. Guess what? Like Auntie says, they cancel out. plus 1. Hey, look at that. They're identical. This bad boy, even. Does that make sense? Are we okay? That's why they're kind of called even, because if you've got enough exponents, it'll cancel out a lot of your stuff. Okay, try this one on your own. Try this one on your own. Take it, plug in a random number, a random letter, and then do the opposite. And if you like the -1, stick with it. If you're like, Missy, can I just do negatives instead without the 1? As long as you realize they might cancel out, you're cool with that. That's it. There you go. Okay. I just watching her do it without it. So here I'm going to stick with X. Why not? Here's my home base. This is what I need to get back to. If I don't get back to this, no good. So I am going to use the -1 trick. You don't have to. Some of you are pretty fast at this, and you're like, Miss T, I got this. 3, it's going to be -1 squared, x squared, plus 5, -1, x. So far, so good. The 3, that's squared, so it goes away. That's looking good. Woohoo! I'm so happy. But notice the exponent here was even, but the exponent here is odd. So look, I'm stuck with that stupid negative. This and this do not look the same. This guy and this guy don't match because of that dude, right? And if they don't match perfectly, guess what? Not even. Not odd necessarily. That's a different thing. At this point, not even. How is that? Is that bad? Are we okay with that? Okay. I got one last one. This has all been second year algebra-ish, maybe a little creeping up to third year. This next one is hard. This next one is hard. I have a lot of my friends who would look at this and eyeball this and said, well, you know, I think I got a pattern here, Miss T. It's got even exponents, it's going to be even. And if it's got odd exponents, it's not going to be even. So I have a lot of friends who would say, not even, just by looking at this. So I want you to set this guy up. And then I'm going to tell you, when you have fractions, there may be a trick. There may be a trick. Just set it up and then stop, and then we'll talk about the trick. Some of you might see it. Look in the negative right there. She got it. Yeah, that's good. I'm like, you keep plugging 5s, and I realized you're plugging in S's. So you can do it. Okay. If I'm seeing people work away, and I'm not going to stop you for a second, and I'm going to do it with you. Leave what you got, because you're like, what? I don't quite get it. It looks like not even to me. It looks like not even. So let's see. I'm going to go ahead. Damn, I hate when that happens. I'm going to keep it as X. Might as well. So here's my home base. That's what I'm looking for in my little proof. You know what I'm doing? I'm doing a little proof. I'm convincing you. I'm convincing you. That's all a proof is. Don't let it freak you out. So here we go. F, I'm going to use a -1 because it helps me, but you do you, right? Here's what I got. -1 to the third, x to the third, plus -1 x over 5 times -1 times x. Anyone see that I've made any mistakes? You're thinking, you're good. You're good. Okay. So here we go. And you're like, Miss T, that looks like -1, because that's to the third power. So -1 times -1 times -1. Those two go away. I'm left with 1 left over because it's odd. So negative 1x to the third minus 1x over negative 1 times 5 times x, or negative 5x. And you're right now you should be saying, that doesn't look anything like that. That's all pluses, and that's all minuses. Guess what I can do? I can do the F word. Let me look up at that. I can factor this bad boy. Watch what I'm going to do. I'm going to take out the negative 1s. So negative 1 comes out, and I'm left with x to the third plus x. And I'm going to take out this negative 1, 5x. Look what happens when you have a fraction. You can cancel the negative 1s as long as you can cancel it from everybody. You're only allowed to do it if everyone has a negative 1 to give. Look, way back here, I could do it. This guy goes, this guy goes, this guy goes. But I can only do that if I can take it out of everyone. So because everything got negative, it's like nothing got negative. So this bad boy, he's crazy. He's even. And that's hard. So we're going to keep working on this, right? I'll just keep sprinkling those in. So I'm done. That is it. You guys did okay with this. You have absolutely plenty of time. Finish the work tonight. It's light work. The answers are on there. It'll take you very quick, and then you'll have no homework, and then it's Friday, and we are counting the days so we get our first fall break ever.